Hello, Professor. My name is Luis Nieto. I'm gonna do my chapter 26 exam. For this, I choose the problem 26.13. Do my part A, given data. Hi. So for part A, you can connect a 10 mega OHM resistor with a series of 3.60 microfarad capacitor with a battery with EMF 11 volts. Before you close the switch at T equals 0 to complete the circuit, the capacitor is in charge. Find the capacitor charge. Alright, for this we have the given data, we have the resistance. We know the resistance is 10.00 mega OHM. And we convert that to scientific notation, so 7.0 and 6 OHM. We have the capacitance, that's equal 3.60 microfarad. And converting that to scientific notation, we're 16 times -6 farads. Alright, now the voltage, that is 11.00 volts. Perfect. To do this, to get the final charge capacitor, it's pretty easy. We just gotta multiply the resistance by the capacitance by volts. So 3.60 10 times -6 multiplied by 11. I'll get that on the calculator. Alright, I got 3.96 10 times 3.96 times 5. Capacitance. Now we'll go with part B. For part B, find the initial current. So the initial current was going to divide volts by the resistance. We already have the numbers up there. We'd have to do it again. Over 10 to the 10th sixth. And I got 1.1, 1.10, sorry. 10 times -6. Perfect. I'm gonna do this and this as well. Now we'll go with part C. So for part C, we have to find the time constant. To find the time constant, we just multiply the resistance by the capacitance. Let me just do it here. We have the numbers already. So resistance, which we know it's 10.0 times 6. And the capacitance is 3.6 times -6. Oh, about that. Let's put that on the calculator. 3.6 times -6. Close right here. And give me 36 seconds. Alright. That's my answer for part C. For part D, we gotta find the fraction of the final charge from the capacitor at time equal to 18 seconds. When we have a new given data here. So given data, the time, that is 18 seconds, and the time constant, there's 36.0 seconds. For this, 1 minus the 36. Alright, so let's get that on the calculator first. So E over minus 18 over 36. I got 0.6065. Subtract 1 minus 0.6065. It's 0.3935. That's the final answer for part D. Now we'll go with part E. For part E, find the fraction of the initial current present at t equals 18 seconds. Technically, it's the same thing. So for part E, we only got to take the 1 out. So 18 over 36. All right, and that's technically what we got here as well. So 0.6065. That's for part E. Now we have to go with part F. So for part F, a 22.20 microfarad capacitor has a limit initially charged 4.20 micro charge. You connect with series with 4.0 mega OHMS resistor and open switch. If t equals 0 is the time you close the switch, at what time the capacitor will be charged at 1.20 mega charge. All right. They have the given data. The given data is going to be the initial charge 4.20 10 times -6. We have the final charge, that is 1.20 10 times 6. The resistance, we know it's 4 mega OHMS. If you convert that to scientific notation, so 0.06 OHMS. And the capacitance, 2.20 microfarads. We can convert that to farads, so 2.20 6 farads. All right. First of all, we're gonna use this equation. We're gonna get the T first. Is that multiplying the resistance by the capacitance. Get that on the calculator. Alright, I got 8.80 seconds. Now we can insert that in the equation. So 8.80 1.20 10 times 6 over and then there's 4.20 10 times -6. Okay, and now we'll get that to the calculator. $1.20 10 times 6, and then 4.20 10 times -6, and I got 11. Perfect. Now we go with part G. For part G, what will be the current in this circuit at this time? We have the initial charge. We already got the information. We have the resistance. It's the same information. The capacitance, same information, and the time. We only had the time, and we needed that, but easy to get the So E equal the nature charge over the resistance, and we multiply that by alright. Let's get the first one on the calculator. Let's get everything on the calculator, to be honest. So we cut time, and we can do it shorter, so I can have more space for 6 E and negative 18 over 8.8. Alright, and I got it for 3.0083 10 times negative 13. Perfect. Now we'll go with part H. So for part H, you can add another resistor in series with a 8 microfarad capacitor and an open switch before you close the switch at t equals 0. The capacitor has a charge of 5.50 micros charge at 17 seconds. The charge has increased 1.10 microcharge. Find the resistance of the resistor. Alright. First of all, we gotta write down the given data. Alright, capacitance, we know it's 8.00. We're gonna convert that to scientific notation, so negative 6. The initial charge, 5.50, 10 times 6. The final charge is 1.10, 10 times 6. And the time, that is 17 seconds. Perfect. For this, cool. Got it. So the resistance, the equation is going to be, we just multiply the charge by the capacitor by the natural logarithm of the final charge and divided by the final charge. Perfect. But and we subtract by the seconds. Trying to find the R. So 17 seconds. Alright, let's get that to the calculator. 17 over 8.00. Let's open parentheses so I can make it easier for me to look at it. Alright, negative 6 multiply. I'll close parentheses, open natural logarithm. 1.10. Was it one? Yeah, 1.10. 10 times negative 6 divided by 5.50. 10 times negative 6. And got 1.32 10 times 6 OHMS. Perfect. For part I, find the current in the circuit used after you close the switch. We already got the number for this, to be honest. Part I I can write it down, I don't mind giving data. We have the resistance, the one we got in the last page. So 1.32, 10 times the net times HMS. And the voltage, it's a 11. Let me see, 11. All right. We're just gonna divide the voltage by the resistance on this one. 1.32, 10 times 6. Let's get that to the calculator. 1.32, 10 times 6. And I got 8.33 times -6. Amazing. Now we have to go with part J. For part J, find the current in the circuit at t equals 17 seconds. All right. Part J. Data. What would change this because we have the initial current. It's right here as well. Let me go part J. Alright. The initial current we know it's 5.21 times -7. The resistance, it's 1.32 times 6. We already got that. The capacitance, 8.00 times -6 farads, and the time is 17 seconds. So we don't have to get that much of given data because we already have everything. Alright. So to get first of all, to get the time constant, we have to calculate the time constant. And 1.32 10 times 6 multiplied by the capacitance 8.00 10 times -6. And let me just get out the calculator. 1.32 10 times 6 open 8.00 10 times -6. And I got 10.56 seconds. All right, now we calculate the current. To calculate the current, we're just gonna multiply the initial current, that is 5.21 times -7, 17 over 10.56. All right, let's get that to the graph. 5.21 times -7. Multiplied by -17 over 10.56. And I got 1.04 times -7. Correct. I'm trying to like I'm trying to close all the less answers so I can part J. So now we'll go with part K. For part K, you connect initially in charge 6.40 microfarad capacitor in series with a 5. Let me see again. 5 mega HMS resistor and a battery with AMF of 12 volts. After letting the capacitor charge for 51 seconds, you disconnect it from the circuits and connect it to a series to an open switch and a 6 mega HMS resistor. Find the charge on the capacitor when you disconnect it from the first circuit. All right. Burn. Okay. So for part K, we got the given data. We have the capacitance, that is 6.40 We're going to convert it right now to scientific integers farads. Now the resistance, that is 5.00 10 times 6 HMS. We have the voltage, we know it's 12.0 volts. And the time, 51.0 seconds. Perfect. To get this, we need to get the time constant first. So T equal the resistance, 5.00 10 times 6, multiplied by the capacitance. So 6.40 times 6. Get that to the calculator. So 5.00 times 6. 6.40 10 times -6. And I got 32 seconds. So 32 seconds. Now, to calculate the charge, pretty easy. Wait. Alright, so charge 6.40, the capacitance by the volts. So 6.40 times -6 multiplied by 12. 7.868, 7.68, 10 times -5. Now, (7.68) 10 times -5 multiplied by 1 minus E is 51 over 32. Cool, got it. So right here, 7.68 10 times -5 multiplied by 1 minus E, -51 over 32. And I got 6.12 10 times -5 charge. Perfect. Now we go with part L. Find the charge on the capacitor 70 seconds after you close the switch in the second circuit. Alright, to find that, we already have the given data. So capacitance 6.40, the resistance, it's a little bit. Alright, so 6 mega HMS. So I'll write it down on mine. Part L. Part L given data. Capacitor, we know it's 6.40 10 times -6 farads. We know the resistance, 6.00 10 times 6 OHMS. The initial charge, 6.12 10 times 5. And we have the time, that is 70 seconds. Perfect. To get the time constant, we multiply the resistance by the capacitance. So we know 6.00 10 times 6 multiply by 6.40 10 times -5. Alright, let's get that to the calculator. 6.4 times 25. Yeah, 38.4. Perfect. Now to calculate the charge, multiply the initial charge. So 6.12 10 times -5 by E. 70 over 38.4. Alright, and we'll get that to the calculator. So 6.12 times -5 multiplied by e minus 70 over 38.4. Alright, and we got 9.89, 10 times -6 charge. Perfect. And that was my exam for chapter 26.